We're going to continue working with the same problem that we looked at in the last video, but we're going to move on to our next step here. So in the last video, just to refresh our memories, we calculated the p-value, and we said that the p-value that we had was 0.0004, and that's what we're going to be using for this step. So we want to make our decision and interpret this decision for this problem. The other thing that we're going to need to know along with our p-value is we need to know our level of significance. So we're going to need to know what this number is, alpha. Alpha is usually a very small number. Think 0.01 or 0.05. At the very largest, it might be 0.1 or 10%. And if 1 is not given, then using this 0.05 is usually a fair assumption. I'll try and always make sure to tell you what alpha is, but if there is a problem in the homework or anything like that that does not tell you what alpha is, you may assume that alpha is 0.05 in that case. So how we're going to make our decision is we compare the p-value against that alpha. So the first case, we've really only got two cases to consider. If the p-value is less than or equal to alpha, so if the p-value is very, very, very small, then our decision will be to reject the null hypothesis H0. Now remember that the null hypothesis was what we assumed to be true. It's kind of what our assumption was for this problem. That's what we thought was true. So if the p-value is less than alpha, the p-value represents the probability that we get a sample like ours if H0 is true. And if that probability is extremely low, then what we might say is, well, perhaps we can't argue with the fact that we were not going to get a sample like this, because we have that. In this case, it was the 41% of respondents so that they were comfortable. You can't say that that didn't happen because it already did. So one of two things has to be true. Either we got extremely unlucky with our sample and we got something that is vastly different than that population proportion of 50%, which is extremely, extremely unlikely. Or the alternative would be, well, we made a mistake. Our original assumption was incorrect, which is when we would reject H0. So if that p-value is very low, then we're going to reject H0. And what that means when it comes time for the interpretation is basically there was enough evidence to make us change our mind. So we change our mind. We no longer believe that H0 is true. And then the alternative, the second case here, is if the p-value is greater than alpha. So if we have a slightly larger p-value, then we do not reject H0. Even if it is unlikely, you might say, there's not quite enough evidence. It's not quite enough to convince me to change my mind. So what we say in that case is there is not enough evidence to change our minds. So what's nice is this decision rule is the same for any type of hypothesis testing problem that we're going to see. And we're going to see hypothesis testing a bunch more in this class. And this decision-making rule never changes through the remainder of the course. So in this case, we have our p-value was, we said 0.0004, and our alpha was 0.05. That was given to us in the problem. And in this case, our p-value is less than alpha. So for us, the p-value is less than alpha because 0.004 is less than 0.05. So what does that mean? That means that we reject H0. So our decision for this problem is to reject the null hypothesis, which then means if we want to interpret this, that means there is enough evidence to support the alternative hypothesis. We no longer believe that the null hypothesis is true. We are now going to support the alternative hypothesis. So if I was going to talk about what this decision means within the context of the problem, I would say something like, there is enough evidence, because there was enough evidence to change our minds. So there is enough evidence to support that. And I want to go back and I want to talk about what we were referencing in the problem. What's the question that we were asking? What's the claim that we were making? So if I scroll back up here, we want to talk about if the proportion of American Facebook users who are comfortable with Facebook creating this list of categories for them is different than 50%. That's a mouthful, and I'm going to try and abbreviate that where I can. So there is enough evidence to support that the proportion of U.S. Facebook users comfortable with Facebook creating the list of categories is different than, it said 50%, so it's different than 50%. So we always are basically just stating what the alternative hypothesis is. In this case, it was quite long. I'll be honest, this is longer than most of the alternative hypotheses that we're going to see, but generally one sentence is enough to interpret this. So in this case, we're saying there is enough evidence to support that the proportion of U.S. Facebook users comfortable with Facebook creating a list of categories for them is different than 50%. We're just stating what the alternative hypothesis is. Now, we want to be extremely careful with the alternative hypothesis with this interpretation of it, because there are some changes that you can make and there are some changes that you cannot make. If you want to use this interpretation as sort of a boilerplate fill in the blank statement, it will work for basically every single hypothesis testing question that we look at. But there are some words that I'm going to point out we are not allowed to use. And the one I want to specifically call out is we cannot ever in these types of problems prove anything. We cannot prove. If you use the word prove within your interpretation, you will lose points because we can't prove anything in a hypothesis test. All we can say is what is likely. And in fact, it is certainly possible for us to make a mistake. Even if we did everything right, we might make a mistake within our hypothesis testing questions. So we want to be careful with that language. There's some evidence or some language that we could use. So in this case, I said there is enough evidence to support that. You could say there is enough evidence to suggest that. There are certain words that we can tweak. And if you have specific questions about your interpretation, you want to run it by me, I'm happy to take a look at it. But the one I specifically want to call out, it's a personal pet peeve of mine. We can't prove anything with a hypothesis testing question. We can only say what is likely.